Hello students, welcome back to my channel again. Today we are going to learn class 11's probability chapters, probability of event A or B, this topic. Now this is the 5th session of this probability chapter. So let's start with the topic. Today we will be learning about probability of event A or B, that is P of A union B. Now for that reason, let's take an experiment. Suppose a coin is tossed thrice. Then sample space will be HHH, HHT, HTH, this one. So these all 8 elements will be there in the sample space S. Now let's take A be an event with the elements. Suppose HHH, HTH and THT. And suppose B be the element with HTH, THT and TTT. So from these two sets or events you can find out A union B very easily. So A union B will be, look, these two are common elements, so it will be like this: HHH, HTH, THT and TTT. Okay. Now we all know that P of axiomatic approach already we have done. So I have written over here, this is P of HHH plus P of HTH plus P of THT plus P of TTT. Now, if all the outcomes are equally likely, then what it will be? And then P of A union B, what it will be? First of all the outcomes are equally likely. That means their probability will be equal to each other. So each element's probability will be 1 by 8, 1 by 8, 1 by 8 and so on. Ultimately all will have 1 by 8 as its probability. So this will have 1 by 8, that means this will be 1 by 8. So we will be writing it, P of A union B will be 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, that means 4 by 8. So it's becoming half. Okay. 1 by 8, 1 by 8, 1 by 8, 1 by 8 ultimately added together and we are getting the result as half. Now what will be P of A? P of A we can find out from here, 1 by 8, 1 by 8 and 1 by 8, that means it will be 3 by 8. Similarly P of B also will be 3 by 8. That means P of A plus P of B will be 6 by 8. 6 by 8 means 3 by 4. Now look at this, half and 3 by 4 both are not equal. So from here we can say that P of A plus B not equals to P of A union B. That means this one, P of A union B not equals to P of A plus P of B. So we are just highlighting it so that you can understand its importance. P of A union B not equals to P of A plus P of B. So what will be its value? We have to find it out. Okay. Now A intersection B will have these two elements in it, HTH and THT. Therefore, P of A intersection B will be like this, and it will be 1 by 8 plus 1 by 8, that is equals to 2 by 8, that is equals to 1 by 4. Now look at this relation, P of A plus P of B minus P of A intersection B. So we are placing its values. 3 by 8, P of B also 3 by 8, P of A intersection B just we have got as 1 by 4. So we can get the calculation like this, and ultimately equals to 1 by 2, that means half. Now this half is actually the value of P of A union B. That means we can say that this relation equals to P of A union B. So this is the relation, P of A union B equals to P of A plus P of B minus P of A intersection B. And this is a very important line, important theory, important result, whatever you can say, but this is really very important. So in your copy also you please mark it as important. Now look at this Venn diagram. This Venn diagram I have drawn just to prove this. We have already proven it with example calculation, but now we will be proving it with Venn diagram, that means set theory. Now if A and B, these round shaped sets, then we will be getting three parts out of it. First part, it will be A minus B. I am just marking which part it is, just like this. Okay, this will be A minus B, this will be A intersection B, and this part will be B minus A. Now these three parts are together. You can say that these three parts are mutually exclusive parts, means disjoint parts. They don't have any common element. So what we can write? We can write A union B. A union B, that means the whole. A union B, we can write that A, this A union B minus A. A the whole circle union this B minus A part. So we can write like this, A union B minus A, where A and B minus A both are disjoint set, both are having no common element, and we can say both are mutually exclusive events. Another thing we can write that only the set B, the second circle, only the set B can be written as A intersection B union B minus A. A intersection B union B minus A, where A union B and B minus A both are disjoint, that means mutually exclusive. So from axiomatic approach we can write P of A union B from first equals to P of A plus P of B minus A, and from the second we can write P of B equals to P of A intersection B plus P of B minus A. Now from these two, if we are finding P of B minus A's value, or we are just omitting it, then what will be getting? Now look at this. From number 1 we can write P of B minus A equals to P of A union B minus P of A. From 2 we can write P of B minus A equals to P of B minus P of A intersection B. Therefore from these two we can equalize both right hand sides. So P of A union B minus P of A equals to P of B minus P of A intersection B. From this just we can take this P of A in the right hand side to get this result. Now look at this. This is our required result that just we have proved. Now think about another case. You think about two sets which don't have any common element. That means we can say that A intersection B equals to phi, or A and B are mutually exclusive. Okay, mutually exclusive events. Then we will be finding that P of A intersection B equals to P of phi. That will be equals to 0. So in this case, this relation will be P of A union B equals to P of A plus P of B, because this part is 0. That means the rest of the part will be like this. P of A union B equals to P of A plus P of B. So this is another condition valid only when A and B are mutually exclusive. Okay, did you understand it? Mutually exclusive sets will give us this condition. Our next point is probability of the event not A. So for this, let's take one die is thrown. So sample space will be 1, 2, 3, 4, 5, 6. Let us take an event A. A event is to get even numbers only. That means it will be 2, 4 and 6. Therefore, A complement will be quite obvious. It will be 1, 3 and 5. Or you can write not A also. Now, if the outcomes are equally likely, then we can write P of A equals to P of 2 plus P of 4 plus P of 6. That means 1 by 6 plus 1 by 6 plus 1 by 6. So it's 3 by 6. That means it's half, right? Now P of A equals to half. P of A dash equals to P of 1 plus P of 3 plus P of 5. That is equals to 1 by 6 plus 1 by 6 plus 1 by 6. Ultimately 3 by 6 and equal to, this equals to 1 by 2. Therefore, we can say that P of A equals to 1 minus P of A dash. Why we can say it? P of A is equals to 1. Right? P of A is equals to 1. P of A P of A prime equals to half. Just we have got. Therefore, P of S minus P of A prime equals to 1 minus half equals to half equals to P of A. Therefore, you can verify this one like this, or you can write down P of A prime equals to 1 minus P of A. Now this is one very important statement, that P of A prime is equals to 1 minus P of A. That means you can write down P of not A equals to 1 minus P of A. So from this relation, if any one of these two are known, other one can be found very easily. Now, in another way also, we can prove it. How? We all know that A intersection A dash always will be 5, because a set and its complement will not have any common point, and A union A dash will be always S. So we can write that P of A intersection A dash equals to P of phi equals to 0, and P of A union A dash equals to P of S equals to 1. So from this, we can say P of A plus P of A prime equals to 1, because these two are mutually exclusive, so we can write it like this. Therefore, P of A equals to 1 minus P of A dash, or P of A dash equals to 1 minus P of A. Okay. Coming to question number 2 of the exercise 16.3, because up to question number 1 we have done in previous session. So from 2 is a coin is tossed twice. What is the probability that at least one tail occurs? Now coin is tossed twice. That means the sample space will be HH, HT, TH and TT. From that at least one tail occurs. That means the event A, or this event will have the set like HT, TH and TT. So you will find out its probability. It's very simple, and like that you have to find out these events sets and their probabilities. This one also very easy. It's a card problem. Coming to question number 5, it is also very simple. Just one thing you have to understand. Now look, question number 5 I'm just discussing. A fair coin with 1 marked on one face and 6 on the other, and a fair die are both tossed. That means this is a coin having 1 and 6 on both faces, and that is a fair die. They both are actually thrown. Find the probability that the sum of the numbers that turn up is 3. Now, what can be the possibility? Possibility can be 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and 6, 1, 6, 2, 6, 3, 6, 5, 6, 6. sorry, 61, 62, 63, 64, 65, 66. There are 12 possibilities. Out of these 12 possibilities, each one will be having the probability as 1 by 12. Now, we need to get the sum of numbers that turn up is 3. So how can we get 3 as a sum? Only when 1 here and 2 for the die, that means 1 comma 2. Then only we will be getting the sum as 3. That means the probability will be 1 by 12. Now, second part is to get the sum as 12. 12 when we will get? We will get 12 only when the first part is 6 and the second part is also 6. That means 6 comma 6, and that is only 1 6 comma 6 over there in the sample space. So its probability also will be 1 by 12. So the first part is also 1 by 12 and the second part is also 1 by 12. Now question number 6. There are 4 men and 6 women on the city council. If one council member is selected for a committee at random, how likely is it that it is a woman? Now look, 4 men, if I am giving the name as M1, M2, M3, M4, and 6 women, if we are giving the name as W1, W2, W3, W4, W5, W6, then, and all 10 members, actually this 4 plus 6, that means 10 members are actually equally likely outcomes. So all will have its own probability as 1 by 10. Now we need to have a council member to be selected at random, and that must be a woman. So what will be the chances? Chances will be 6 times. That means 1 by 6, 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10, like 6 times. So it will be 6 by 10, and 6 by 10 is 3 by 5. So 3 by 5 is the answer. Coming to question number 7. It's a very interesting question and important too. A fair coin is tossed 4 times and a person win ₹1 for each head and loss ₹1.50 for each tail that turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. Now look, a fair coin is tossed 4 times. So first we need to have its sample space. You will find out the sample space because this will be your homework. I'm just making you understand the process. Now, how you will arrange those 4 parts of a sample point? What it can be? What are the possibilities? Number 1, 4 times we can have head. So what will be the amount? For each head ₹1 he is winning. That means here he will be winning ₹4. Second possibility, 3 heads 1 tail. That means ₹3 winning and ₹1.50 losing. That means 3 minus 1.50. So it's ultimately ₹1.50 winning amount. Third possibility, 2 head 2 tail. 2 head, that means ₹2 winning amount. 2 tails means ₹3 losing amount. So we are ultimately having losing ₹1. Fourth possibility is 1 head 3 tails, winning ₹1 and losing 4.50 rupee, means 4.5 rupee. So ultimately we are getting the result as 3.5 rupees losing amount. Fifth possibility is all four are tails. That means there is no winning rupees, only losing, and that will be rupees 6 losing amount. Now from the sample space you have to find out their probability. That means you have to find out how many these events are there. Question number 8 is very simple. Question number 9 is very simple. Question number 10 is also very simple. Look at question number 11. Question number 11 is, in a lottery, a person chooses 6 different natural numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? Now look, hint is given, order of the numbers is not important. That means the person who wins needs to get those 6 numbers in any order. Okay, so what we have to first find out. Now look at the solution. Now 1 to 20, there are 20 numbers. Okay, 1 to 20. We need to find out 6 numbers group, one group of 6 numbers. Now one group of 6 numbers from the numbers 1 to 20, how can we make it? We can make it in many different ways, and the number of ways are 20C6. 20C6 will give you the result 38,760. You can calculate it. You will be getting this one. I know it already, that's why I've written. Now, these are the total arrangements, number of arrangements that can be happened for choosing one group of 6 people from 1 to 20. We need to have from these number of groups, we need to have only one, and that is the winning group. Okay, this is the winning group. So from 38,760, 1 is the winning group and we need to find it out. So what will be its probability? Its probability will be 1 by 38,760. I am again just repeating the whole concept of question number 11. Question number 11, we need to find out a 6 numbers group, that is winning group, set by the lottery committee, and we need to choose those 6 numbers from 1 to 20. How many ways we can choose this group in? So that will be 26 ways, and its answer is 38,760. Out of these number of arrangements, only one group is winning group. So how can we choose that one group? That probability will be 1 by 38,760. Now look at question number 12. P of A equals to 0.5, P of B equals to 0.7, P of A intersection B equals to 0.6. And there is another one question with these statements. Now we need to check whether the following probabilities P of A and P of B are consistently defined or not. Now look, P of A, P of B, you just think about the diagram where two sets are intersecting each other. So that intersection part will never be more than a set. Intersection part always will be subset of that set. So probability of the intersection part always will be less than probability of the full set. Now look at here. It is given 0.6 and it is given 0.5, which can't be possible because probability of intersection part will never be greater than probability of the whole set. So this is not defined. Coming to the second one, probability of the union always will be greater than probability of each individuals. Now look at this. This is 0.8 and this is 0.4, 0.5. I'm repeating my words again. Probability of union of two events always will be greater than individual probabilities of events. And here it is greatest. So the second statement given is defined or valid. Coming to question number 13. Question number 13 is very easy because you just need to put all these numbers in that formula. P of A plus P of B minus P of A intersection B is equals to P of A union B. And there you need to place these values to find out the blank spaces. Coming to question number 14. P of A equals to 3 by 5, P of B equals to 1 by 5. We have to find out P of A or B, that means A union B. Now there is a condition given. A and B are mutually exclusive events. That means P of A intersection B equals to 0 for this. So P of A union B will be this plus this. That means 3 by 5 plus 1 by 5. So it's 4 by 5 and that is the answer. Next, question number 15. If E and F are events such that P of E equals to 1 by 4, P of F equals to half and P of E and F, that means P of E intersection F equals to 1 by 8, find P of E or F, that means P of E intersection F. It's very easy directly from the formula. Now P of not E and not F. P of not E and not F, this part needs to be done. Now for this question, look at this figure. If this universal set, that means that is sample space, inside it there are two sets A and B, two events. Now we have to find out P of not A, that means A dash, and means intersection, not A intersection, not B. Now, not A intersection, not B, before we find it out, we will be just writing one thing. A union B's prime is equals to A prime intersection B prime. We know it from De Morgan's law, right? Set theory, De Morgan's law, this one. So we can write that P of A prime intersection B prime is equals to P of A union B's prime. Now we can write this one from the formula P of A dash equals to 1 minus P of A. From this formula we can write this one as 1 minus P of A union B. Now here they have taken E and F, so it will be 1 minus P of union F. And from the first part of the question, you have already got P of E union F's value, and just put over here, you will get the answer. Question number 16 tells that events E and F are such that P of not E or not F equals to 0.25. State whether E and F are mutually exclusive. Question number 16. What is given? It is given that P of not E, that means E prime, or means union F prime equals to 0.25. So again we will apply De Morgan's law. We know E prime union F prime equals to E intersection F prime. That means we can write down P of E intersection F prime equals to 0.25. This one can be written as 1 minus P of E intersection F equals to 0.25. From this we can write down P of E intersection F equals to 1 minus 0.25, that is equals to 0.75. Now look at this. Its probability, P of E intersection F's probability is 0.75, which is not equals to 0. Now if its probability not equals to 0, that means this one can't be phi. That means E intersection F not equals to phi. That means E and F are not mutually exclusive sets, events. Okay, so this is the answer. Now question number 17, which is very easy, and this one you will do it. Question number 18 I am doing here. Question number 17, 19, 20 and 21 will be purely your homework. Rest all questions are actually your homework, but these three I will not even discuss. Okay, so question number 18 I am just making you understand. In class 11 of a school, 40% of the students study mathematics and 30% study biology. So mathematics is a cluster and biology is a cluster. 10% of the class study both mathematics and biology. That means this is their intersection point. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. That means it will be their union part. So what is given for question number 18? It is given, think about taking mathematics is the event M. So P of M equals to 40 by 100. That means 4 by 10. That means 2 by 5. And studying biology, taking the event as B, so it's P of B, that is equals to 30 by 100, that means 3 by 10. And both mathematics and biology, so P of M intersection B, that is equals to 10 by 100, that means 1 by 10. We need to find out P of M or B, that means P of M union B, and this you all know the formula, P of A plus P of B minus P of A intersection B. So from this formula we can put all three values and we can get the final result. So my students, I hope you all have understood the whole exercise properly, and I'm sure that you all will be practicing it in your own copy. So that's all for today. Thank you, everybody.